Hello, so this is WF7i Homebrew. I just wanted to do a quick update video on my little multi-band receiver project. So last time I left you, I had just kind of drilled out this hole with my Dremel tool for the display, my frequency counter display. So this will give me my frequency display. This actually mounts back behind here. And basically what I've done on this project, and I haven't made a lot of progress, it's been really slow. I'm very, very slow at building things right now. I just got a lot of other things going on. But, excuse me, but I have kind of put together this box, I guess you could say. So what I've done is I've mounted the main tuning capacitor here, and I put in a fine tuning variable capacitor over here, and I just made the decision I wanted to use air variables, just kind of a maybe an aesthetic choice, or just because I think it's kind of cool to use air variables. So this will be very small fine tuning, and this here will tune across the whole band. So the idea again is it's going to be an 80, 40, and 20 meter CWSSB receiver direct conversion. So I kind of decided for this project what I would do is kind of get the box prepared first and then kind of mount the circuit in the box and start working on the circuit later. It's a little bit backwards from what I usually do. Usually what I'll do is kind of put the circuit together, see if it works, and then put it on a board and then try to put it in a box. But this time around, this is a circuit I'm already kind of familiar with. I pretty much know it will work, and I wanted to go ahead and get kind of the infrastructure box thing out of the way because I thought it might actually be easier to test it and to make changes when you have kind of all these components in kind of a nice, neat box. So what I did is, so those are a couple of things I put on there. I also have my power switches up front here. I've got a headphones jack here. And then I put in a piece of copper clad board. So this is the main circuit board that I'm going to mount all my parts to. And then what I do is, it's called Manhattan style construction. You basically kind of put little islands, glue them on the board, and then the little islands are the nodes, the circuit nodes that you'll solder your components to. I've got some pre-printed little Manhattan style circuit board pieces here. So like these here are little 8-pin IC Manhattan style little cutouts here. So you just sort of peel one of these off, and then on the back you glue this, put some glue on the back of this, paste it down on the board, and then I can take my integrated circuits like my NE602 chip here, and it'll just kind of solder down onto this little Manhattan board here, if that makes any sense. And what I'm going to do with the ICs is actually put a socket on them, so I don't ever just solder ICs to boards, because if anything goes wrong, and it's a pain in the butt to take it off. So those will be socketed. So again, this is a really simple circuit. I kind of already illustrated it before, previous video. It comes out of the Experimental Methods in RF Design book. It's one of the first circuits in the book. But it's pretty effective. Now, it's not a great radio circuit by any means. There's much better ones out there. But I like it because it's simple. It's very simple, very few parts. And it gives me an opportunity to kind of play around with some things like making some little filters, low pass, band pass type filters. It's just kind of easier to put together. You get a higher parts count, then it kind of necessitates having a cleaner layout, or maybe actually making your own circuit board, which I don't really want to make my own printed circuit board and etch the copper and all that kind of stuff. I have done that and I can do it, but it's more effort. Anyway, I just kind of wanted to experiment around with this simple circuit a little bit more, get a little bit more mileage out of it, play with it a little bit more. So that's kind of the game plan. So all I've done so far really is just, as far as the circuit is concerned, is put in a regulator chip. It's a little three lead voltage regulator chip. I think it's a 78L I forget the number on it now. I have a bunch of them in my junk box. But basically what it is, it's an 8-volt regulator. And so if the power supply voltage changes between 9 and 12 volts, it ensures that roughly 8 volts are supplied to the circuit. And that just gives you a little bit more stability. I always try to put some kind of regulator or Zener diode or something in my circuit to kind of keep the voltage stable. And I don't know how well it shows up here, but this is my power jack. This is an M style power connector, M like Mike. You can kind of see there's a center pin on there. Most of my kit rigs, QRP radios and homemade radios and stuff, I use this type M connector. There's some accessories in ham radio that also use it. I just found it to be a pretty convenient little DC connector. I have a little portable battery by Bieno, or however you pronounce that, Bieno, that I use for soda. And I also have a little connector like this on there. Now I may also put a little 9-volt battery clip here. And I've got a little clip back here somewhere, right here. So I'm thinking about just putting a little 9-volt battery clip right there. And so I can run this off a 9-volt battery as well. So, I mean, there's different options. You build your own radio, you can pretty much put whatever kind of feature you want in there. So it's just kind of nice. The other thing that I highly recommend for anyone who's building anything is a reverse polarity protection diode. It's a single element, but it can really save your butt. And I've been lazy and not put these in previous circuits. But all you do is just put in a forward bias diode in series with the power. And if you try to put reverse polarity, this diode cuts off and it won't allow current to flow in your circuit. Simple as that. So that's a real simple thing, real cheap, easy thing to put in to protect yourself from blowing out a bunch of chips. Now this circuit's so simple, honestly, if I blew out a couple of these chips, there's only 2 chips in it, so I could replace them. But anyway, I'd rather not have to deal with that. This here is a little RF gain control back in the back panel. So all that does is your signal comes in from the SO239, and I did put in SO239 because that's what most of my RF connectors are in the shack. I'm not going to use BNC. I'm not going to use some funky connector. I like having a standard SO239. So I put that on there. The center conductor goes to the pot, 5K pot, audio taper. Audio taper is kind of important so that you can actually witness gradual changes in volume as you turn the knob. If it's linear taper, most of the changes will happen as you get up towards the 5K level, and the rest of the time you're just kind of turning a knob and nothing happens. So I like the audio taper. Anyway, so I just take the center pin of the SO239, comes over here to the pot. Output of the pot comes out, and right now it's going to nothing. So I still have to kind of wire that up. I think I actually wired something wrong here. I'm just looking at that. This is ground. Yeah, so no, this is right. I'm sorry. Yeah, this is correct. So the output of the pot is actually going to this little coax right here. The braid of the coax is going to the ground of the box, which is this bolt. The center conductor is the other side of the pot. So it comes out here. It's going to go to my multi-position switch. And then this here, I'm going to be able to switch between the different bands. So I've got like 80, 40, and 20 right here. These are the 3 different bands. And so this is going to, it's kind of hard to show what this is, but there's going to be 3 different positions here, and each one of them will select different filters for 80, 40, or 20 kind of bandpass filters. And then the output of that filter, it's then going to go to my oscillator, which is then going to go to the mixer chip. And that's what I still have to build. The oscillator is going to involve both the main tuning and the fine tuning. I've already got some component values. So for instance, for 80 meters, I have a inductor, and I've got some capacitors that in conjunction with this main tuning will give me the range that I need for that band. So I've already sort of gone through that process. It's just a matter of putting the parts on the board. So I hope that's of some interest to maybe some people. I'm going to go ahead and cut it off here. It's already 10 minutes, but I'm going to try to finish this up in the next week. I have time off. I can actually do that. If anyone has any questions or anything, feel free to drop me a note. And I hope some people might find these videos interesting. 7 threes. Until next time.